Hey everyone, I'm Anurag Sarkar, and on behalf of my co-authors in this video, I'll be talking about our paper that introduces a new PCGML approach for generating levels that blend multiple games, where we extend prior work in game and level blending by using an increased number of game domains and introducing a new path and affordance vocabulary. Our work continues a recent trend of a more creative form of PCGML that focuses on learning models capable of generating content outside of the domain used for training. We've seen several techniques for this, such as domain transfer, blending separately learned models, building game graphs using learned models of different games. But the prior approach we must specifically build on is learning a new blended domain by training a latent variable model, like a variational autoencoder, on multiple domains simultaneously. More specifically, we extend this prior work by increasing the input domain for blending from 2 to 6 games, thus significantly expanding the possibility space for the learned blended domain in terms of producing new content. Since each game has its own specific representation, we also introduce a new affordance vocabulary that unifies level representation across all the games. The affordances we use were inspired by the video game affordance corpus and consist of 10 core affordances which can be combined to create new affordances. Here we have an example each from Ninja Gaiden and Mario, showing an original level segment which is translated to its domain-specific tileset, which is in turn translated to a unified tileset as defined by our vocabulary. We also annotate all input levels used for training, with paths generated by an A-star agent tuned using the specific jump arcs for each game. This allows us to capture some of the gameplay behavior and mechanics of the original games in addition to level structure. Also, unlike prior work, this enables us to generate blended content that is mostly playable, as shown in these examples. Finally, we train two types of VAEs, one consisting of linear layers, the other consisting of layers of GRUs, which to our knowledge is the first use of a GRU VAE for PCGML work. Based on our evaluations, we found that the GRU VAE is better at both learning the level structures and patterns within the games, and also producing more playable levels. Qualitatively, we have your example interpolations between Mario and Mega Man using both models. We see that the levels, and especially the paths produced by the GRU model, are less noisy, but the linear model produces a more discernible interpolation where one domain very clearly and obviously blends into the other. Now, the paths and jump arcs in the generated blended levels as shown previously could enable extraction of physics models for these new blended domains. And for more on that, you can check out our collaboration appearing at XI this year. And finally, in the future, we'd like to extend our approach to vertical orientation such as levels in Kid Icarus, and also to games and genres other than platform.